Hello everyone, this is Ali Reza from drhsolutions.com. This video series is for students who want to take SAT Level 2 Math exam. Different subjects in the test will be reviewed in this video series. The first topic is about functions. First, we go over the definition of a functions, then polynomial functions are explained. After that, trigonometric functions are reviewed, exponential and logarithmic functions will be reviewed, rational functions and limits are explained, and then miscellaneous functions are discussed in this video. So, an overview of the function. So a function basically takes inputs and based on the process produces outputs. For example, y is equal to square root of 3x minus 1 divided by x is a function. So for any value of x, there will be a unique value for y. So this is an example of a function. But because this function has a square root, the value 3x minus 1 should always be greater than or equal 0 because it is not defined the square root for negative values. And also because x is in the denominator, therefore it should not be equal to 0 in order to have a real value for y. For definition of a domain is all the input numbers that a function can take. For example, for the above mentioned function y, 3x minus 1 should be greater or equal to 0, and also x should not be equal to 0 because it is in the denominator. Therefore, x should be greater or equal than 1/3. All right, so because x is greater or equal than 1/3, therefore it also includes that x is not 0. Therefore, one definition for the domain is enough, which is x greater or equal to 1/3. All right, the range is the output numbers of a function. So all the values that y can take is the range of a function. So different definitions for functions are given. For example, x plus y is a set of numbers of x and y's, 2 or 3, 3 and 5, and 5 and 6. So this is a function. So it doesn't need to be an equation. It can be any form like a set of numbers or pairs of numbers. A circle equation, which is x squared plus y squared equals r squared, is not a function because all the values of y should be unique for a unique value of x. So a circle basically is not a function. Okay, in another example, a set of numbers are given. If f equals set of 4 and 5, 6 and 8, 7 and 9, 4 and 8, 5 and 6 is to be a function, which term should be removed. So as you can see, for value x equal to 4, there are 2 y's. So this can't be in a function. So for any value of x, there should be only 1 y. So therefore, the term a, 4 or 5, or 4 and 8, one of them should be removed. So the answer A is correct. So for any value of x, there should be only 1 y, and this is not in this case. In another example, for functions of graphs, if you want to distinguish if a graph is a function, here is another example. Which of the following graphs is a function? So in order for a graph to be a function, any vertical line that you draw on the graph should cross the graph at only and only one point. So if you look at answer A, if you draw a vertical line, and it will cross the graph at only one point. For any value of x, it will cross only one point. For the part B, if you draw a line, it will have vertical line, it will have many points on the graph. For part C, if you draw a line, vertical line, it will cross the graph at 2 points. So this is not a function. For part D also, a vertical line will cross the graph at 2 points, right? So it should only cross at 1 point. So answer A is the only graph that is a function. All right. Okay. What values, another example, what values should be excluded from the domain of the function y equals square root of x minus 1 divided by 5x minus 10. So as you can see again, we have a root, square root actually, which the value below that or inside that should be greater than equal to 0, because for negative values an even square root is not defined, and also the denominator should not be equal to 0. So if x minus 1 is greater than equal to 0, then x should be greater than or equal to 1, right? So this is the range, the domain of the function actually, right? So in order to the square root to be defined and have a valid value, x should be greater than 1. And for the denominator should set equal to 0, 5x minus 10 equal to 0, so x will be 2. So if x is equal to, it will make the denominator 0, and then so it will not be possible to have a real value for y. Therefore, x equal to 2, and the values that are x less than 1 should be excluded from the domain of the function. Please note the word excluded, so it's very important. So the answer B is correct, because x equal to should be excluded, and also x less than 1 should be excluded. So the B is correct. So it's not all the values that should be included in the domain. It's all the values that should be excluded. That's what this question is asking about. All right, so we have a function combination. So if we have two functions, we can have combination of functions. For example, we can add two functions, which is the sum of functions. So if f of x and g of x are given, f sum of functions is f plus g of x equals f of x plus g of x. So simply we add two functions together, so it will give the sum function. We can have difference functions, so we subtract two functions. The definition of a functions, two functions, we just simply subtract one from the other, and it will be a difference function. We can have a product function, which we multiply two functions together, so it will be a product function. Or it can be a quotient function, so we divide two functions and we introduce another function, which is a quotient function. For this one, the denominator should not be equal to 0, and this is an important fact. A composition function. The composition function is f or g of x, which we replace g of x instead of x inside the function. Or g of f, right? G of f of x, which is g of f of x. It means we replace f of x into x in the function g of x, right? So these are different combination of functions, and the composition function is very important in these terms. All right, let's see. An example, f of x is given 2x and g of x is given x squared minus 1. Find the following functions. F plus g of x, so we simply add two functions. So we add 2x plus x squared minus 1, and we rearrange that, as you can see here. X squared plus 2x minus 1. We write it just in the order, descending order of the powers. And f product of two functions, f dot g of x, we simply multiply 2x times x squared minus 1. So this will give us the product function. And the quotient function, f divided by g of x, which is 2x divided by x squared minus 1. So for the quotient function, the denominator should not equal to 0. So those values, which is x equal to minus 1, and plus 1 should be excluded from the f quotient function, right? F over g of x. The composition function f or g of x, if we just replace x in the f of x function with g of x. So it will be 2 times actually g of x. So it will be 2 times x squared minus 1. So it will be 2x squared minus 2. G of f of x. So this is the where we replace f of x inside the function of g of x. So we replace 2x inside x in the g of x. So it will be 4x squared minus 1, as you can see here. So this is an example how these values are calculated. All right. So there's another example. If f of x is equal to 2x plus 5 and g of x is equal to 3 to the power of x, then what is f of g of 2? So we simply need to find the composition function f of g of 2 and see what the value it is. So we first go and calculate g of 2. So in order to calculate g of 2, we just replace 2 instead of x in the function g of x. So it will be 3 squared, which is 9. So g of 2 is 3 squared equals 9. And we just replace 9 inside the f of x. So it will be 2 times 9 plus 5, which is equal to 23. So the answer is D for this function.